Okay, so this is the 2025 High Level Maths Leaving Cert Paper 2, question 6a. Find all 6 solutions to the following equation in A, where A is between minus 360 and plus 720. Sine A is equal to a half. Okay, so what we're going to do is we're going to, well, we'll write this down first anyway. Sine A is equal to a half. So the first thing we got to do is just think where exactly the angle could be. Well, we're looking at sine A equal to plus a half. So sine is positive in the first quadrant, so it can be this angle anyway. And it's also positive in the second quadrant. So it can be this angle here and it can be this angle here anyway. So let's look at these two angles. So this is going to be our reference angle here and this is going to be our actual angle here. So we got to do sine inverse a half. That's equal to our angle. And alpha then would just be equal to 30 degrees. The sine of 30 degrees will give you a half. So that's the angle we're going to be dealing with anyway. So this angle here is going to be 30 degrees. That's one of our solutions anyway. This angle here is going to be 180 degrees minus 30. Remember, this angle here is 30 degrees down here. That's our reference angle. This is 30 degrees here as well. So 180 minus 30 will give us 150 degrees. So really what we're looking at are two solutions, 30 degrees, and then we've got to add 360 degrees a certain number of times, and then we're going to look at 150 degrees. We're going to add 360 degrees a certain number of times as well. So I'm just going in the anti-clockwise, the positive direction first. We'll deal with the negative ones in a few minutes. So if we take n is equal to 0, we'll get 30 degrees. If we take n is equal to 1, we'll get 360 plus 30 degrees. So if this is n is equal to 1, so one solution then will be 390 degrees. We take 150 degrees plus 360 degrees times 1. That'll give us a solution of 510 degrees. If we take n is equal to 2, that'll give us 750 degrees. So we can see from what we have up here that we're outside the range. We've gone past 720. So we don't include this one here. What about 150? Well, that's going to be outside as well. So these two here are going to be two solutions anyway. Let's look at subtracting then. Let's take 30 degrees and subtract 360n. Let's take 150 degrees and subtract 360n times. If n is equal to 1, then we get 30 minus 360, which gives us a solution of minus 330 degrees. And that's within our range. If we take 150 and subtract 360, that'll give us minus 210 degrees. That's within our range. And again, if you take 2 here and 2 here, we will get numbers that are outside the range. So for example, 30 minus 2 times 360 will give us minus 690. So this is n is equal to 2. So this will give us minus 690 degrees. So again, you can see up here that we can only go down as far as minus 360 degrees. So this one we can't use, and it's going to be the same here as well. So in other words, our answers are 30 degrees, 150 degrees, 390 degrees, 510 degrees, minus 330 degrees, and minus 210 degrees. These are our 6 answers, and you can put those into your calculator. Just find the sign of each of those and you will get a half. Okay, let's move on to the next question then. F of x is the following function where x is real and in radians. F of x is equal to the modulus of 4 sine x minus 1. Part of the graph of f of x is shown below. Write down the period and the range. Okay, so if you take your, let's say, standard sine function, let's do it over here. It's going to look something like this. It's going to come up, down, and then up again. This is going to be 1 here, and this will be minus 1. This is 2 pi out to here, and this is pi here. So the period is 2 pi, and the range is minus 1 to 1. So this is going to be the same thing. However, we've got a couple of numbers that we have to take into consideration. First of all, we don't have any coefficient of x. So the period should really remain the same. However, the modulus will affect the period in this particular case. First thing that will happen is that the modulus will make everything positive. So in other words, this part of the graph here will be flipped up to this part here. So in other words, what you'll end up with is another graph that'll look something like this. It'll start here, come up, down, and so on. So again, this is going to be 2 pi out to here. This is going to be pi here. We'll just look at this 4 as well. The 4, what that 4 will do is change the range from -1 to -4 and +1 to +4. But because we flipped it around, this now is going to be +4 up here, and you'll have 0 here, of course. So the period has now changed from 2 pi to pi because it's now repeating from here to here. So the period is now going to be pi. So the period is equal to pi. Now the other thing that we've got to take into consideration here is this -1. And what the -1 will do is take the entire function and move it down one place. So in other words, what we'll end up with, if I draw a third graph, the entire graph will move down 1 unit. So we'll end up looking at something like this. And again, this is 2 pi out to here, but it repeats every pi. And the range now, because we've moved down from 4, down 1, this is now 3 here. We've moved this down 1, so this is -1. So the range then is just going to be -1 up to 3. Okay, let's look at the next part. See, in the triangle ABC, AC is 2, BC is 3, and AB is 4. Use the cosine rule to find the value of tan CBA without using a calculator. Give your answer in the form root n over m, where n and m are integers. Show all your workings out. Okay, so let's do the cosine rule. So we're looking at this angle here. So we've got to start opposite that at 2. So you're going to say 2 squared is equal to 3 squared plus 4 squared minus twice 3 times 4. And then the cosine of the angle opposite this side, which is, let's say, B here. So let's work all this out. We're not allowed to use a calculator here. So this is 4 is equal to 9 plus 16 minus 3 4s are 12, 2 12s, 24 cos B. Okay, so 9 and 16, 25. Bring that over to the other side. That'll give you 4 minus 25, which is minus 21. So you have minus 24 cos B. And then finally, cosine of B, divide by minus 24. Minus divided by minus is plus, so it's just 21 over 24. So we can simplify that a little bit. So let's see, we've got cos of B is equal to 7 over 8. Okay, so we've got to now find the tan of B. So if you take a right angled triangle, and this is B here, the cos of B is 7 over 8. So this must be 7, this must be 8. We'll call this x here. So to work out what x is, you take x squared plus 7 squared is equal to 8 squared. So x squared is equal to 8 squared minus 7 squared. X squared is equal to 64 minus 49. X squared is equal to 15. X is equal to the square root of 15. So this is the square root of 15 here. We've got to work out the tan of CBA, so the tan of B. So our answer then is the tan of the angle CBA is equal to the square root of 15 over 7, the opposite over the adjacent. Okay, and that's it for this question.